Hi, everyone. Kate Meredith here from Glass Education and unofficial den mother of data sonification and leader of the GeoSonNet. We are really glad to have everyone here today, and we're going to go through some quick introductions, and then we'll get to our speakers and some announcements. So let's start on my top row. Matt, let's start with you.
Hi, Matt Fleener, University. Oh, there's two Matts?
Yeah, that's okay. We are two Matts, but go ahead with Fleener.
Matt Fleener, University of Mary Washington in Virginia physics program.
Ed Garcia, I'm a physics student at the University of Mary Washington.
Excellent. Matt Henry, go ahead.
Good morning, everybody. I am part of the Everett group, coming to you from Columbus, Ohio, and always enjoy these meetings. So
okay,
thanks
Steve.
for having me.
And I'm Steve Everett. I'm also part of the Everett group. Matt and Kathy Bailey Allen and I are the three independent evaluators that are helping Kate assess exactly how well things happen with GeoSonNet and the Sonification World Chat. Also happy to be here.
Okay, Kathy, you just got introduced, but you got anything else for us?
Nope, that'll work. I'm Kathy Bailey Allen, and I'm happy to be here as well.
Okay, Cheryl Fogelhatch.
Hi everyone, Cheryl Fogelhatch. I'm a museum accessibility researcher and consultant in Baltimore, Maryland, and I'll post my new thing in the chat.
Ooh, sounds exciting. Okay, Adrienne.
Hello, I'm Adrienne Provenzano. I'm a STEAM educator and musician, and I connect the arts and humanities with STEM fields and currently working on an educator presentation about biomimicry.
Ooh, very exciting. We're going to go over to Micah.
Hello, I'm Micah. I'm a math student at the University of Louisville. I've been really interested in data sonification.
And very active on the Slack channel, which if you haven't joined yet, strongly suggest that you do. I'm finally getting really much busier on there, and the link to that is in the agenda. Bruce, you're up.
I'm Bruce Walker. I'm a professor at Georgia Tech. I've been doing sonification for 30 years and use it in a lot of applications in assistive technology and accessible education related to everything from images, maps, graphs, charts, diagrams. I'll leave it there.
Okay, thanks, Bruce. And Carrie, I've saved you till now. You can just introduce yourself and give us your, I had the Island Conference announcement on the agenda. You want to just
Sure.
promote that for a second?
I can do that, sure. My name's Carrie Sapalo. I am a research developer at the Educational Testing Service in Princeton, New Jersey. I recently switched teams. I work on the Accessible Content Inclusive Solutions team now, or ACES. And I have been working for, oh my gosh, almost a quarter of a century now in the accessible STEM arena. And this fall, I'm chairing the 16th annual Inclusion in Science Learning a New Direction, or ILAM conference at Princeton University, September 26th and 27th. And we have an open call for abstracts for presentations closing July 1st at 11:59 p.m. Eastern Time. So if you haven't submitted or were thinking about, please do so. And we will not be doing any abstract submission extension this year. And that website is islandconference.org.
Thanks, Carrie. I believe that I put that into the agenda, which I also posted to the meeting chat. And I will be attending that conference this fall. There is no travel money for GeoSonNet in that, but I'll figure out how to get there anyway, because I've wanted to attend for a few years and they're doing some focus work on sonification. So you can read my abstract that I submitted last week and the link to that is in the chat. So, and thanks to Carrie, I've also been invited to submit an abstract to speak at ETS. And with the reviews that I've been doing of Carla Scaletti's work and looking back on some history with data sonification, I would like to be talking about can testing be the leader in unifying for data sonification and pushing it forward through that educational framework. So I'm going to dabble in that area. So Carrie, get ready for my abstract. It's coming. So, and I'm going to save our speaker introductions until for just a second, and then because we have Chelsea Cook and Brandon Biggs here with us today, but a couple more announcements from the community. We had Soleil Hyman was here last time and gave us a heads up on the SonNet conference, which is also in our agenda, the link to. I'm wondering if anyone had been giving any thought to attending that. I think it should be a very good project. So Bruce is going.
I've been invited to be a keynote speaker.
Okay, excellent.
And I'll probably also pitch. I've also pitched a talk on the Sonification Studio.
Okay. So sorry about that. And yeah, that would have been a really cool one to attend or to have been, I'm surprised that I was hoping that we would garner some interest. But I'm glad to see that Bruce is there and we can maybe get some attention for GeoSonNet vicariously through Bruce. So take a look at that. It looks like it'll definitely be worthwhile, especially in focusing in the use of sonification for data analysis. All right, and if you have anything else to add there, Bruce, just go ahead and add it in the agenda. So the other announcement I have is that I have not heard back from AGU yet about the town hall that we have proposed for December. I'm not sure how quickly they work, but I kind of expected to hear back like within a month or so, but we'll keep following up on that. Maybe Amy will have some information for me later. And for July's GeoSonNet, Robert Alexander is going to be presenting that during that one, and I look forward to getting that one set. I believe we'll be looking at the 9th of July, so coming up will be a quick turnaround on that one in 3 weeks. And then after that, we will, for August, I want to start talking seriously about where can we look for money. And given the given how things have shifted since this grant started in terms of uncertainties with the National Science Foundation and NASA, I want to start a conversation and do a little bit more leadership in terms of maybe writing a proposal and getting it out to foundations. And I think the educational piece of it, again, reviewing Carla Scaletti's work and our work here, is that approaching the standards or data sonification, the interpretation piece of it, and looking at what kind of help we can give there to move the ball down the field might be really worth our while. But I want to have a community-wide discussion about that, and I'll be talking to the advisors on this and posting to Slack so we can get some structure around what we want to poke at in August, because we'll be coming up on a year and it's time to start writing, even though we don't know quite where the money is going to be or who to propose to at this point. So with that, I think that covers it. And does anyone else have any community-wide announcements or things that they would like to push here? Okay. Awesome. Okay, so Adrian, did I let you introduce yourself? Did I forget you today? Okay, I'm just losing it. It's been lots of traveling in my last couple of weeks.
I was going to suggest you introduce yourself.
I kind of quickly did that at the beginning.
Okay.
Yeah, and so and I'm going to get us started. I was looking at so all roads seem to lead back to Georgia Tech and Bruce Walker, because I have talked to more people at Georgia Tech in the last 6 months than any place else, and all connections seem to go there. And Brandon Biggs was another one of them, but I actually met up with his mom at the POSB meeting where they were introducing some of the tools for that Brandon is going to be talking about today. And it's just really exciting. And to find out that Brandon also is at Georgia Tech was fun. So I had a great time talking to him. And Chelsea Cook is going to be presenting today to kind of kick us off in terms of what is the motivation, where are some leverage points for us as a community to look at, that whole idea of funding, or where do we find the motivation, where can we possibly find the inroads. But Chelsea is going to talk to us about her user experience as a blind person working professionally in the area of websites and compliance with laws, and going to talk to us about what her experiences are and her work. So Chelsea's going to give us a little bit of our introduction. A lot of us are familiar with WCAG. The link to the basic information is in the agenda. If you would like to see something more extensive done after you hear these presentations, let us know. So with that, I'm going to let Chelsea take it over, and we're going to start with Chelsea and move on to Brandon a little later.
Thank you, Kate. My name is Chelsea Cook. I'm currently in Denver, Colorado. I can give a little bit of background about current work, but I can also give a little bit of background about my journey in science and astronomy and how I met Kate. So I graduated from Virginia Tech in 2015 with a bachelor's in physics and minors in astronomy and mathematics. I guess actually my first experience with sonification, oddly enough, might have been with Carrie Sapalo in high school. I helped him with his PhD thesis. After that, I did internships at Space Telescope in 2012, where I worked a little bit with Wanda Diaz-Merced. The tricky part with working with her was the tool that she developed it, so everything was in her head, and it was a little hard for me to figure out what things were meaning in terms of sonification. In 2016, I worked at NASA Ames trying to do a little bit of programming, and then I moved to Colorado in 2017. I guess my university affiliation might be the University of Denver, just because the job that pays the bills, I work in state government doing accessibility, but the job that makes me feel human is I tutor math and physics for DU. And I've really enjoyed that. My science career has been a little bit rocky just because I think part of it has to do with programming, part of it has to do with networking, part of it has to do with every single engineering job now requires AutoCAD, so that's fun. But I'm in state government for now and trying to get back into science eventually. Should I stop for questions or keep going? Okay, I guess I'll keep going. So my job in state government, I work for the state of Colorado Office of Information Technology as an accessibility consultant. Basically, I liaison with a couple of agencies that and help them work through getting their things accessible. We have a statutory law in Colorado that all government services and websites, internal and external, have to be accessible. So that's pretty awesome. And then I also do side projects. And one of the side projects that I do and I enjoy is giving screen reader lived experience demonstrations because there are several screen reader users on this call. Everyone kind of knows how it works and how it goes. But for people who have never heard a screen reader before, it can be pretty insightful and pretty empathetic. And oh, that's how that's broken. Okay. So I enjoy giving those. I'm going to give a mini demo today of a map, and then Brandon is going to tell us how to make that map accessible from what Kate's told me. Oh, of course, I forgot how I met Kate. I met Kate, I don't know when we first met, Kate, but I basically in 2022 took all my vacation time and did a crash course internship at Glass. Got a conference presentation out of it, so that was pretty fun working on a Redshift project. And it was very enjoyable to get back into science again. So does anyone have questions, or should we go to the demo, which I can start setting up?
Okay. Yeah, my apologies. I have an office full of interns, and I am forgetting that I am trying to mute my my mic occasionally. So Chelsea, yeah, go ahead if you want to share screen. We'll get you going here.
Zoom share toolbar window, system dialog. Zoom.us has new window.
I'm using VoiceOver on macOS. I'm going to try and slow it down a little bit.
Content chooser. Navigation. Characters, words, window spot, content chooser, navigation. More menu item, more menu item. More menu item, more menu item. Z.
Okay.
More, show meeting, show participant.
Well, the keyboard command to change the rate just left my head. So is that too fast for people?
I think we can swing it. That's not fast.
Okay.
Safari. Safari, post attendee, Zoom window, link image, close tab.
Leif Karlstrom has joined the meeting.
Checking online.
Okay, so in order to not throw any of my government agencies under the bus, I am using a site that is commercial. It's sport clips for people to get a haircut. Someone recommended it to me as a map that didn't work very well.
And
the window
Chelsea,
Yep.
we're not seeing the map or the website. We're just seeing a black screen.
Screen curtained off.
How about now?
There you go. Got it.
Okay. Do I need to maximize the window?
You've got a lot of things open, and the website is you could take up a little bit more real estate if you would like it.
Heading level 2, ready to come in. Heading level 2, ready to come in, main. End of list, main. Vertical collect side tool, full screen, minimize, but full screen. Safari, map and directions for haircuts near vertical line sport clips window, sidebar table.
Better.
Collect vertical map and direct main. Heading link, checking online.
Thank you. Sometimes I don't usually come to these because work, but we'll try this. So I'm going to go by heading navigation.
Heading level 4, join sport clips. Heading level 4, over 1,800 last heading level 4, over 1,800 locations.
Maybe.
Map scale, 500 kilometers for 55 pixels. Keep link, drag map, toggle, end, show satellite, show street map, menu, map, keyboard, interact link, end of, or search along ending address, edit text with autofill menu.
So I could put an address in here, but I can do that in a minute. I'll just show the map as it is. I don't know if there's actually a map showing or if you need to put in an address first, but we can go through the map. So I'm just going to go VoiceOver right arrow.
End of, or search along route, link, show locations. Interactive Google locations map. Search results are at the heading locations, region.
So it does tell me that if I want to search, it'll give me stuff by headings, which is nice.
Keyboard shortcuts button.
There's a keyboard shortcuts button that basically controls the zoom.
Map, empty map.
Empty map. Cool.
Google Maps image of location and surrounding area image. Google Maps image of location and surrounding area image. Google Maps image of location and surrounding area image. Google Maps image of location. Google Maps image of location. Google Maps image of Google Maps image of location. Google and toggle full screen view and menu bar.
Okay. No, you're just there's so many images.
Show satellite imagery submenu 3 of 4. Show street map checked submenu 1 of 4 menu bar. Map empty map. Google Maps image of location and surrounding area image.
Come on.
Google Maps image of location and Google Maps image of location. Google Maps image of location and surrounding area image. Google Maps image of location. Google Maps image of location. Google Maps image of location and 2 more items group. Menu bar. Toggle full screen view toggle button. Map camera controls collapse button. Drag Pegman onto a map to open street view button. Link image. Open this area in Google Maps. Opens a new window. Keyboard shortcuts button. Map scale 500 kilometers per 55 pixels. Click to toggle between metric and imperial units button. Link terms. End of interactive Google locations map. Search results are at the heading location.
And that's all we got for the map.
So Chelsea, can you go through and interpret what people were hearing here? Because what I know that there was some definite highlights in there in terms of accessibility. Can you just comment on that?
Sure. So the map seems to just have alt text of Google Maps of location. There seems to be a lot of those. And I couldn't tell if the screen reader was getting stuck or if there were just lots of those images. And then it was mostly the visual controls. You have the scaling and the street view and the
From Adrian
thing.
to everyone. I
thing
noticed
that-
it said empty map,
Sorry.
but didn't specify it's a map of the continental US.
Oh, yeah, that'd be nice to know. So yeah, it did say empty map.
Yeah, and that's what we're going to be talking about today. But for those of you who aren't familiar with these screen readers, what you are seeing, for those of also visual, the screen reader will tab through in terms of there's different ways that you can approach getting into the page, and you could see where her screen reader was accessing by the box that was around the different elements. But we noticed that sometimes you even lost the element box in terms of navigating around the screen. So this, in terms of WCAG requirements, is the next step in the evolution of accessibility for these websites, is to provide something more meaningful than empty map. And Chelsea, how does that affect you in terms of your own use of the websites?
It can depend. If the map is the only option, and if you search for a location and you just get map results, then that's not very helpful. Where exactly is this? Usually what I have to do if I'm looking for a location of something is I have to put in an address or put in, the city and state that I want to find something in. And then I have to actually switch over to Google Maps to get directions to it if I want to do that, or figure out sort of what place it's in. This could also be because they're technically embedding the Google Maps little widget thing. Could be Google's fault in terms of making it more accessible. But again, it just seems like there were more visual controls than anything else. And so if you can't see the visuals, the map doesn't help you. So yeah, usually I just have to hope that the location search has a good list view. And if it doesn't, then the website's not very useful.
I'm going to open, Chelsea, was there other things you wanted to show us on this site, or should we open it up for some questions?
We can open it up for questions. Let me switch back to Zoom so that the notifications aren't blathering in your ear.
Zoom.us. Zoom.us. Zoom share toolbar window. System dialog.
And I can stop sharing. Yeah, Kate said to make it a little bit quick, so I hope that was helpful to people.
So what we're finding is that the basic requirements for WCAG in terms of accessibility of websites, we're hoping is going to provide us an opening for greater use of sonification, and
Right, because
might be another in. Go ahead, Chelsea.
Oh, I was just going to say, because right now one of the principles of WCAG is perceivable, and it's, can you access everything on this site? Can you perceive in a big or sorry, people are putting stuff in the chat and I'm losing my train of thought. Perceivable means, can you get to the information? Does it make sense to you? The others, just for people's knowledge, are operational, understandable, and robust. So I guess the map could also be under understandable as well. And I'm still learning about WCAG, so I don't have the specific success criteria where sonification would help with this. But yeah, I think it's a great solution. So if it can be embedded in web applications, that would be kind of fun.
And Chelsea, what is your day-to-day job? Not the one that feeds your soul, the one with the state government. What is it you are doing to review websites?
Sure. So that's the one I was mentioning before, where I help agencies figure out how to make their content accessible. So I'm not actually reviewing most websites in a testing audit capacity. Sometimes they'll ask me, hey, what is your experience with this particular element or this particular page or this particular document? But most of it is doing people work and a little bit of technical work in terms of helping them make their products accessible.
Okay. Other questions?
Yeah, I was wondering, when you're talking about accessibility, are you talking about accessibility primarily for blind and visually impaired people or people with any sort of disability?
We are trying to make it as inclusive as possible.
Thanks.
Yep. I mean, I'm blind. I'm a screen reader user, so I do focus it from that end. But we, as I said, we're trying to include everybody.
I'll just
Bruce?
jump in. This is Bruce. I'll just jump in and say that for those of you less familiar, the Mac screen reader is built in, so you can just turn it on and start playing with it. And you don't have to install anything. So that's a low entry way of exploring what this world is all about.
And
Yeah,
of
no,
the- Go ahead.
that is kind of nice. That's one reason why I primarily switched to the Mac, is so that I could always have a screen reader. For people who want to try it, and for people who are used to other screen readers, there are tweaks now in the preferences that you can turn off. Apple VoiceOver works a lot differently than the common Windows screen readers like JAWS and NVDA. But over the years, they've added little toggle switches where you can turn some of VoiceOver's weird behavior off, so it behaves more like JAWS. Mostly, it's the grouping behavior that people have trouble wrapping their heads around.
Okay. And as far as the tutorial on the Mac for the screen reader is about as good as it gets, because I have tried out a number of different tutorials over the years to teach, and I don't find anything better than just going through the tutorial that's available to your Mac.
And you can also use the trackpad. It's great.
All right, if there are no other questions, we want to launch into what can we do about those inaccessible blank maps and visuals on our website and on websites. And so Brandon, I'm looking forward to you giving your tour, because that was an eye opener for me, both at the POSB meeting and when we spoke last month. So yes, and as Bruce pointed out in the chat, soon to be Dr. Biggs.
All right, are you seeing my screen?
Yes, we are.
All right. Okay. Sorry for my screen reader. One second. Okay. All right, so I am a PhD student at the Georgia Institute of Technology, and Bruce Walker is my PhD advisor. So small world, and hi, Bruce. So all my research is completely focused around non-visual digital maps and spatial diagrams. So my main objective is to create an interface so that AutoCAD and Esri and Google Maps and Apple Maps and Bing Maps and all these different, tools that are out there, and the different architecture software tools and all that kind of things, all those different types of interfaces are fully accessible, especially to blind people, because right now, as you saw, thanks, Chelsea, that was a very good demonstration. The experience is really bad. So as part of my PhD work and master's degree work, So I have a master's in inclusive design, and as part of that, I began my work on non-visual digital spatial diagrams, and now I'm continuing that research as part of my PhD work. And I'm not going to go into the example here. So I actually have that exact demo that Chelsea just gave. So I'm going to skip through that here. So blind people aren't the only ones who have issues with geographic maps. We heard the screen reader experience, which is basically blank. But people who are keyboard only users also have a significant problem with maps. They're not able to select the different features that are on that map. They're not able to draw with the map on the map. And they're also people who are low vision aren't usually able to zoom in up to 200% so that they can actually see what's on the map. The contrast is not usually very good. People who are autistic oftentimes want some way to virtually explore a location before they actually go, and a lot of maps don't allow for that kind of fidelity. And maps are usually only visual. So I can go on and on and on. Illiterate people as well, people who can't read, are also unable to use maps because they have require you to read text, and so you can't listen to the map and have it read out to you. So at the end of the day, there's about 20% of the population who can't use geographic maps in their current format, and that's a lot. So it's not just blind people. The National Federation of the Blind, which is the largest institution, the largest community group for blind people in the world, passed a resolution in 2024 calling on all federal agencies and institutions of higher education to adopt inclusive digital maps. And so this is not something that, it's just, Chelsea and I saying this is a problem. 50,000 blind people voted on to pass this resolution to say that this is a problem for the entire world, and especially in particular the US. And so this is basically we're kind of starting a movement here, to make spatial diagrams accessible. The Web Content Accessibility Guidelines, or WCAG, we talked briefly about them, but I want to emphasize what they are a little bit more. They're a collection of 70, I want to say 78 or 79 success criteria that most of the digital accessibility legislation around the world are pegged to. So in the US, we have the ADA, which is now tied to the WCAG guidelines. European Accessibility Act is tied to the WCAG guidelines. So WCAG is really the standard when it comes to digital accessibility. And so there are 15 criteria that are very applicable to geographic maps, but the three most important ones are that most of the maps, all the maps fail right now, is keyboard accessibility, which it basically means you need to be able to use the map with the keyboard. Non text contrast. So if you have something like colors representing data on a map, then you need the contrast is not enough to pass the WCAG guidelines. And so there's a bunch of techniques to get around that, but most of them, none of the existing digital map tools use it. And then there's the one that we're going to focus on primarily today, which is non-text content, which is section 1.1.1. So I would tend to think that is probably the most important section. It's the very first criteria. And section 1.1.1 states that any non-text content needs to have a text alternative that serves the equivalent purpose. And so when it comes to sonification, even if you only have sound, and maybe that's accessible to somebody with hearing, it's not necessarily accessible to somebody who's deafblind. And so a lot of the work that I do couples sonification and visualization with textification. And textification is really the only legally required representation technique in WCAG, and it's the only one that that you need to have. And so all the work that I do has an aspect of textification to it. So there are three ways, well, four ways right now that maps are made accessible. So there is the turn-by-turn directions, nearby address searches. So basically what we saw there with the Google map, where you enter in an address and it comes up with a list of all the different locations associated with that address, tables, and simple alternate text. So those are what are traditionally used to make accessible geographic maps. And the primary issue with those is that they lack any spatial information. So what I mean by spatial information is I use this framework where spatial information is comprised of landmark, route, and survey knowledge. And basically, this is the distance, direction, shape, size, orientation, and general layout of all the points, polygons, and lines. And if somebody is using a map, then they intended to communicate this spatial information along with whatever else is on that map. So if it's a COVID statistic map, they intended you to understand that there are statistics, like, COVID cases associated with the geometries on that map. So if there was a map on that website, the purpose of that map is to communicate the spatial information. And otherwise they would have chosen a different type of representation, like a table, for example. So when a blind person is only presented with a table, then they are not getting the same, they're not able to use that map in the same way that a sighted person would. So that's where this the spatial knowledge framework comes in. And so the point that I'm working on here is, how do we communicate all this spatial information equally to a visual map? So here is an partial accessibility conformance report that we did on the top digital map tools. And the top most accessible digital map tool is Bing Maps at 57% compliance. And it again fails those three criteria that I mentioned previously, but it also had a bunch of other issues that it had. And then Google Maps is at the very bottom at 6% compliance. So if you're looking for an accessible map, do not use Google Maps, whatever you do, because it's very bad. So anyway, that is a recent publication we just had at the CSUN conference this last year.
This is Chelsea really quick, because I may have to drop. Thank you very much. This is awesome. I would say too, one of the other accessibility categories is some people have embedded in their maps is mouse hover. So you can hover over different locations and have it do different things or show different things. And if you can't use your mouse, that's also hard and problematic. And lots of people besides blind people can't use your mouse. But I also do want to say that your skill set and your product, if you turn this into something, that would be awesome. Because the Esri is a huge problem in government. They're kind of the only game in town in terms of vendors, and so they in our case, they refuse to make their stuff accessible. So this is awesome.
Well, let me go on. I'm going to skip through because we're primarily focused on digital maps, so I'm not going to talk about why paper tactile maps aren't particularly applicable here. You can't have a paper map on a website. And there are these tools coming out, like graphic displays like the Monarch, but again, they're not really text-based, and most people don't have a Monarch because they cost about $18,000 a piece. So they are, and they're really still fairly rudimentary. Like, they just came out last like couple months ago, so they're very, very new, and they're not necessarily a good solution to this whole spatial diagram accessibility problem. So that's where the tool that I'm building comes in. It's called Audium. It's the first digital map and spatial diagram tool that everyone can use. The The experience, the non-visual experience, is very similar to a video game where users hear the name and sound of objects as they move a character around the map using their arrow keys or touch screen or other controller. Here's an example.
First tier section in Nixon Hall. First ramp, trash cans along with ramp. Second row table, west in Nixon Hall.
So you move around a user-specified distance. So in this particular case, it was about 1 meter, and you can adjust that to be however big or small you want it to be, and you can jump between different features in a particular direction. So here's an example of so the Audium is basically based off of a couple different co-designs that we've done. So I started back in 2017 with looking at audio games, which are games that can be played completely using audio that are often made by and for blind people. And if you haven't checked out audio games, I highly, highly recommend it. They're very fascinating. You can go and kill zombies. You can move armies around a map to, strategize and defeat and conquer castles or whatever. There's all different types of audio games, and it's all in audio. These are very map heavy experiences, and this was the only time in my entire life where I ever used any kind of geographic map as a blind person. So when I started working on this, I used audio games as my inspiration. So we then performed a bunch of other co-designs and ran a few other small studies validating this type of an interface that I was just showing with Audium, and we've run I think about 5. Yeah, we've published 2 co-designs so far, and then we have 4 that are pending on different aspects, including a drawing experience or touchscreen experience, an indoor map experience, a neighborhood map experience, and a COVID statistic map experience. So here's an example of how our campus map experience sounds like. And if you have headphones, this is where I would put them on. This is a non-visual version of an Audium campus map. We're currently at the Visitor Center, and we want to go to the Flight Project Center. I'm going to open a list of all the actions you can do in Audium that's first letter navigable by pressing F2.
Open main menu, enter. G, get G, go to dialog. Enter, go to dialog object, clickable, search property page object combo box collapsed has, enter, search property page. F, A, T, down arrow, JPL building 321, Flight Project Center. Enter, toolbar, go button, down arrow, listen button, down arrow, description button, down arrow, directions button. Enter, JPL building 321, Flight Project Center, building is 333.9 meters ahead and to the right. So we can tell it's quite a distance away ahead and to the right. I'm gonna escape out of this dialog. Escape. And turn on a radar. Radar enabled. That will beep in the direction that we need to go and get faster as we get closer. Now I'm going to use my arrow keys to move around the map. Every arrow press will move me 4 meters in that direction, and that's because I have my step size set to 4 meters. I can have it set to whatever I want it to be. Right arrow, JPL building 249, Visitors Center, building 301. And what we heard there was the name of the object that we're on, Visitor Center, the type of the object, building, and some coordinates that tell us where we are on the map, along with a short sound representing the Visitor Center. Right arrow, empty space, 3. Empty space just means that there's no data for this location, which is pretty typical for maps. There's a lot of empty space on maps. Right arrow. Now I hear a building to our right, and I'm going to go investigate it. Right arrow, JPL building 339, Cuisine Cafe. Cool, there's a cafe to the right of the Visitor Center. Now I'm going to open the Nearby Objects menu and see if there's a road that we can follow to the Flight Project Center. I'm going to press F2. Open main menu. R. Nearby Objects menu. Filter objects 1 of 9. Down arrow. JPL building 300. Down arrow. JPL building. Down arrow. Mariner Road. 35.6 meters ahead and to the right. So the road is ahead of us and to the right. I'm going to close out of this menu. Escape. Application. And go find the road and follow it. Up arrow. Empty. Up arrow, Mariner Road, 320, right arrow, Mariner Road, right arrow. Now, I hear something behind us, and so I'm going to go investigate and see what that is. Down arrow. JPL building 301. Project formulation.
Cool, so project formulation is in between the visitor center and the flight project center. I'm going to return to the road and continue.
Up arrow. Mariner Road. Right arrow.
All right, and we finished the road, but I hear that we're super close to our destination, so I'm going to continue.
Right arrow. JPL building 321. Flight projects center.
And we've made it! So the really magical thing about Audium is that it runs on the exact same data that a visual map runs on. So GeoJSON, Esri databases, any kind of vectorized data is something that can be shown in Audium. And if somebody has a PDF of their campus map or whatnot, it really doesn't take that much time for us to turn that into a vectorized experience. That's a very off the shelf. You can just Google cartographer on Upwork or something like that and find somebody who can do this. So it's a
I
very
want that right now. Oh, sorry, Brandon.
Well, it gets better. So let me continue on. So here is an example of a COVID statistic map. So I showed you a navigation map, which is what are called referential maps, and they're where the features themselves are the most important. But here is a thematic map where there's some kind of numeric or categorical variable overlaid on top of the geographic features.
The visual version of Audium allows users to switch between colors and patterns, adjust the border width of features, zoom in up to 200% without squashing interface elements, and customize the interface to be how they want it to be. The non-visual version of Audium has two modes, a geographic view and a tabular view. The tabular view has a row for each of the features on the map and a column for each of the properties associated with those features. We find a feature of interest.
Down arrow. Montana. Down arrow. Alaska. Down arrow. North Dakota.
And a column of interest.
Right arrow. 292,604 North Dakota. Row 4 total cases. Right arrow. 383,964 North Dakota. Row 4 cases per 1 million.
And we heard the pitch that's relative to the other pitches in the column. So we can tell that North Dakota actually has a higher number of cases per 1 million than the other rows. We're going to press enter.
Enter. Map.
That'll jump us to the center of North Dakota and switch the statistic on the map to cases per 1 million. Now we're going to use our arrow keys to move around the map 50 kilometers each arrow press, and use a technique called weaving to explore the border of North Dakota.
Right arrow. Down, left, down, left, up, down, left, up, down, left, up, arrow, left, up, right, left, up, right, down, right, down, right, up, right, down, right arrow, down.
And what we got there was the size and shape of North Dakota, the distance, direction, orientation, and general layout of all the features around and including North Dakota. And we learned that Minnesota has the highest number of cases per 1 million bordering North Dakota, but North Dakota actually has the highest number of cases per 1 million out of all the different features we explored.
I forgot to let the screen reader read out, but basically after I would press the right arrow, it would say something like Minnesota, 366,000 cases per 1 million. So I just did it really, really fast, but it would have said, if I would have let it read out, the name of the state and then its COVID statistics for that particular state.
Hey, Brandon, this is Amy. I think I know what weaving is, but can you say what, because just... Can you say what that is?
Yeah, for sure. So it's basically, so since Audium is more of an avatar experience, you can't really trail along the side of something, like you would if you're like the border of something. So in order to understand the shape and orientation and size of an object, you need to go to the edge of that object and then kind of weave in and out with your arrow keys to understand, is how the border is along with the state next to it. So that's basically what I was doing really, really quickly. I was going left to right, down, left, down, right, down, left, down, that kind of thing until I reached the end of the edge of that border. And so this is one way to do it. There are a couple different ways to get the borders of features, but this is the best way that we've found so far. And it's a kind of a convention that is very unique to this type of what I call interactive alt text map. So we've done a couple different evaluations using Audium. We have two published evaluations of Audium, and then we have two pending publications. So the most recent evaluation that we did, we just submitted it for publication, was looking at random geometries for a COVID statistic map or a thematic map. And so we had 25 randomized geometries with random COVID statistics on them. And we asked participants to, we had 20 blind and 20 sighted participants participate. And we asked some of them to analyze and answer questions about the geographic information. So, for example, what state along the East Coast has the highest number of COVID cases, or what state bordering this, state has the highest number of COVID cases, that kind of thing. And what we found was that so we had sighted people use a visual map, audio map, and a table, and then the blind people used the audio map and the table. What we found was that the table communicated no spatial information. Both the visual map and the audio map were significantly better at communicating spatial information than the table. And the qualitative responses that we received from participants was that the table just was useless. So they weren't able to answer any of the spatial questions with the table without guessing. And we also found that there was no statistically significant difference between the performance of sighted participants on the visual map and the audio map. So that was really promising. So that's just an example of one of the studies that we've done on Audium.
Brandon, this is Amy again. Quick question on the table. What I thought was interesting in your demo with North Dakota, was that you went to the table and you said, I want to know about North Dakota. So you arrowed down to that, then hit enter, and it jumped you to the map right at North Dakota. And that seemed valuable to me as a use for the table. It may not have answered your test questions in your evaluation. It may not have been useful for that, but it was useful for finding a starting point on the map, I thought.
Yes, so tables are very useful for things that tables are very, very good at. This is what we found. So if you have questions like what state has the highest number of COVID cases, don't use a map for that. Use a table, because a table is going to allow you to get that information much more quickly than a geographic map would. But if you have a question like what state bordering California has the highest number of COVID cases, a table is going to be almost useless in that example. So the table, it was really good, is really good for some things, and like you saw there, you can connect a table with the geographic view. We also use menus oftentimes. So like you saw in the neighborhood map example, we also have a menu, which is another representation of the data to show the geometries based off of distance. So that's also another useful experience to have. So we've got a lot of different types of representations in this map that we're using and kind of connecting them together and using them what each of their strengths are. So we are now extending Audium to things outside of geographic maps. So here's an example of Audium on a human skeleton.
We are on an Audium skeleton diagram, and I'm going to use my arrow keys to move around the diagram. Every arrow press is about ½ an inch. I'm going to press the down arrow.
Down arrow, frontal lobe, 230.32, 1362.
And what we heard there was the name of the object that we're on, frontal lobe, a sound representing the object, and some coordinates that tell us where we are on the diagram. I'm going to continue.
Down arrow, frontal lobe, down arrow, orbital cavity right, 230.
And now we're on the orbital cavity right. I'm going to open up a menu of all the objects on this diagram by pressing M.
M, filter objects submenu 2 of 159.
There are 159 objects on this diagram. I'm going to down arrow.
Down arrow, orbital cavity right is right here. Down arrow, frontal lobe is 1 step up submenu 4. Down arrow, central midfacial region is 3 steps right. And down arrow, zygomatic bone is 5. Down arrow, orbital cavity left. Down arrow, nasal aperture is 3 steps right and 5 steps down submenu.
And I'm going to hit enter.
Go 2 of 6.
And get directions.
D, directions sub, enter. Nasal aperture is 3 steps right and 5 steps down.
And this is as the crow flies, so I'm going to go ahead and do 5 steps down.
Down arrow, orbital cavity right. Down arrow, orbital, down arrow, or down arrow. Down arrow. Orbital cavity right. 2.
And then
D. Nasal apertures 3 steps right.
now I'm going to move to the right.
Right arrow. Central midfacial region. Right arrow. Central. Right arrow. Nasal aperture 200.
And we made it.
And so that is an example of how we would show something like a skeleton diagram. And there's a lot of other, functionality that we are working on to, kind of optimize some of these diagrams. But I also wanted to show a real quick demo of the way that we're allowing blind people to draw in audio. The Audium shape creation tool allows us to create points, polygons, lines, cutouts, multi-polygons, and add sounds to all those different shapes. I'm going to open our drawing menu by pressing Shift B.
Freehand 1 of 3.
And we've got freehand drawing mode, which allows us to drop points in any configuration that we want.
Down arrow. Rectangle creator 2 of 3.
A rectangle creator, which only requires a point on the bottom left and the top right, and it'll pre-fill the other 2 points.
Down arrow. Compound shape 3 of 3.
And a compound shape creator, which is for things like a square with a triangle on the top, which is typically a house.
Down arrow. Freehand 1 of 3. Alert maps 25. Enter. Application. Audio.
So I selected freehand, and I am going to now move around my Audium character with the arrow keys. Each arrow press will move me 1 coordinate in that direction. So I'm going to drop a point here with Shift D.
D. Point 1. 1 added.
And I'm going to press the up arrow key.
Up arrow. Empty space. 1, 2.
So our first point was at 1, 1. Now we're at 1, 2. And I'm going to go to 2, 2.
Right arrow. Empty space. 2, 2.
And drop a point.
D. Point 2. 2 added.
Now I'm going to create this triangle by going right.
Right arrow. Empty space. Down arrow. Empty space. 3, 1. Zoom level 10.
Arrow. And I'm going to drop a point here.
D. Point 3. 1 added. Left arrow. Surface. 2, 1.
And we can tell that a surface was created in between all the different points that we have. And if we decide to zoom into our map.
DDD. Dash 0.7 dash 0.5 meters each dash 0.25 meters each step.
Then we can see that there is this slant on our shape.
Right arrow, surface, up arrow, surface, up arrow, surface, up arrow, surface, up arrow, empty space, left arrow, surface and point 2, 2, right arrow, empty space, down arrow, right arrow, empty, down arrow, right arrow, down arrow.
So since Audium is a grid, the slanted curve part of the triangle looks like steps to us. So I'm going to go find this point on the right.
Down arrow, surface and point.
And zoom back out to our 1 coordinate step.
Equals 0. Equals 1 meters each step.
And now I'm going to save the shape.
Add ring, free, S, save submenu 3 of 4. Enter, create object dialog object name description geometry type. R, I, A, N, G, F, E, 1. Tab, triangle 1, description edit multi-line blank. Tab, geometry type combo box polygon collapsed. Tab, editable properties table, short sound edit row 2 key column 1. Right arrow, edit row 2 value column 2.
And I'm going to select a sound here. This is the table of the different properties that we can have on our shape, and we can add any custom properties that we want. So this is a short sound, and I'm going to hit enter.
Enter, combo box collapsed has autocomplete editable blank. Down arrow, blank, expanded, down arrow, airports short, list, airports short 1 of 80. Enter, airports short edit. Down arrow, edit row, left arrow, looping sound edit row 3 key.
And this is a looping sound.
Right arrow, edit row 3 value.
And I'm going to down arrow on this one.
Enter, down arrow, blank, expanded. Down arrow, airport loop. Enter, airport loop edit.
And now I'm going to save.
Tab, add new property button. Tab, save new object button. Enter, maps 25, shape created, application, audio map is.
And now we can preview this shape that we just created.
Left arrow, triangle 1, 2, left arrow, triangle 1, 1, up arrow, empty space, 1, 2, right arrow, triangle 1, 2, right arrow, empty space, 3, 2, right arrow, empty space, down.
And now I'm going to create a rectangle.
Freehand 1 of 3, down arrow, rectangle creator 2 of 3, alert maps 25, enter, application, audio map.
And I'm going to drop a point here.
D, point 4, 1 added.
And go up to the right.
Right arrow, empty space, 5. Up arrow, right arrow, up arrow, empty space, 6, 3. D, rectangle created.
And if we down arrow,
Surface, 6, 2. Down arrow, surface endpoint 4, 6,
we
1.
see that the point was added in an area we didn't go. And I'm going to save this shape.
Add ring, S, save submenu, enter, create object dialog, object name, description, geometry type, B, O, X, 1. Tab, box 1, description, edit, tab, geometry type, combo box, polygon, collapsed. Tab, editable properties table, short sound, edit, row 2, key, column 1.
We're going to add another short sound.
Right arrow, enter, down arrow, blank, down arrow, airport, down arrow, alcohol shop, short 2 of 80. Enter, alcohol shop, short, edit. Down arrow, edit, row 3,
And a looping sound.
enter, combo box, collapsed, down arrow, blank, down arrow, airport loop, down arrow, ATM, down arrow, bar loop 3 of 55, enter, bar loop, edit. Tab, add new property button. Tab, save new object button. Enter, maps 25, shape created,
And we can go preview this shape as well.
left arrow, box 1, right arrow, box 1, 6, up arrow, box 1, 6, 2, right arrow, empty space, down arrow, empty space, 7, 1.
We can also create empty boxes, so like an outline of a box, by creating a line instead of a polygon. So I'm going to create, use the freehand creator mode.
Freehand 1 of 3.
I'm actually going to stop that there. There's a bunch of other different cool drawing techniques that you can do there. So there's a bunch of different pros and cons to interactive alt text. Like I was saying, the pros are that it's the exact same data that is shown on the visual map. The ultimate goal is that a user will be able to draw and create and then preview the exact same geometries and sync them up with the Esri database or whatever, geographic information system tool is being used. And the exact same statistics that are being pulled into that map are also being shown on Audium in real time, because Audium is a dynamic experience. It doesn't require any manual creation or work to make it look, to put it into Audium. And but some of the major cons are, the shapes are very gritty, like I was showing, and it does require some technical knowledge to be able to use. Also, Audium is opening up the conversation now with blind people in the sighted community about how terrible the data is that sighted people collect about the world. They don't even have doorways on OpenStreetMap to tell you where the entrance to the building is. And that's something that blind people desperately want. And for the first time with Audium, they're actually able to articulate that and say that this is something that they want. Sidewalks are starting to become more common, but doorways are still missing, which is really wild. Anyway, so this is our vision with Audium is that this is the platform that other tools can use to become fully accessible. So I'm actually attending the Esri User Conference this summer, and I'm going to be talking to them about integrating Audium into their products. But what we really, need is for people to be asking for digital accessible maps and expecting them on all the websites and tools that they're using, because it's now possible to make accessible maps. We just need to do it. So what questions do you all have for me?
Where do you get this?
Well, depends on if you want to use it for your own personal use or if you're a government agency or institution who wants it. For your own personal use, you can go to audiom.net. So audiom.net. And we have an OpenStreetMap integration where you can search for any address and it'll pull up a neighborhood of that location. We also have our COVID statistic map. I'm still in the midst of creating a gallery of all the really cool tools that we've created. We've done airplane seat maps. We did the eclipse map last year. We've done all kinds of maps. I just need to put them on a single web page where people can go and explore them all.
So Brandon, I had a question. Thanks for the presentation. This is Adrian. Is Is this something that could be applied to something like a Landsat satellite imagery or any of the other Earth science imagery that's taken, whether it's visual imagery or taken by other scientific data, but then a visualization is created? That's what I'm kind of wondering about, that sort of application.
Right now, everything needs to be vectorized, so it needs to be computer readable. And so basically, somebody needs to take that satellite imagery and turn it into something that a computer can read. So traditionally, if you'd have a picture, there's no information about what that picture is that the computer can use to analyze it, use to analyze what exactly is going on there. So probably not at the moment. If there is some kind of probably down the road a bit, what we could do is take the color gradients on that photo and sonify those color gradients into some kind of description, or understand what's going on in that photo. But since it's an image, then there's no semantic information, and so you wouldn't be able to understand that this is a road or a building. And right now with Audium, that context is super, super, super important. And so at the moment, satellite imagery is not, by default, is not really accessible yet. But for something like like an ultrasound, where it's a smaller scale experience and you really only have one type of variable, that's something we can definitely do.
So how do you find out if something is vectorized?
Usually, if it has some kind of if it has some kind of in like geographic database ending, so like SHP or GeoJSON, or even DWG for AutoCAD in some circumstances. So the person, there would have had to have been some person manually go in and redraw that diagram in a map or a geographic information system database in order to make it in something that Audium can use. Gets usually done in professional cartography. And if you are a state agency always has their data in that kind of format. So usually the people who are working with this data know if their data is vectorized or not. And most of the time it is. And there's a big push right now to make sure as much of the data is vectorized as possible in just about every industry. So it's a little bit technical to figure out if it's vectorized, but if it's a JPG file or, a PDF file, then it's not vectorized.
Okay, great. Thank you.
This is Chelsea. Sorry, I got excited in your presentation. This is just, I have a feeling that between this and some of the Python sonification I've done and some of the SVG coding that's out there, everything's going to come together at some point. But thank you for this presentation. This was amazing. I am definitely going to go check this out. Definitely for personal, possibly for work. I did have a question on the campus map. So you were at the road. Does it tell you, or is it in stereo or something, like if you need to cross the street, or if maybe it just moves to the other side as you keep moving?
Yeah, so usually if it depends on the data again, so what it shows whatever the data is there. So if you need to cross the street, if there is a crosswalk there, then it will tell you that there is a crosswalk there. If there are if there is an intersecting street, then it'll tell you that there is an intersecting street there. And so sometimes in that particular case, the road just kind of ended. And so, or it kind of, it turned off to go to another direction. And our particular building was still in that direction. So the best way to think about it is that if you've ever touched a tactile map, the road is going to you're going to feel that line going curving upwards, or just completely ending, and then there's a building that is a couple inches away from that road, and you can make an inference that that building is really close to that road. And so in that particular case, you can tell that, hey, this building's really close to that road, even though there's a bunch of empty space in between the road and the building. You can kind of, make a guess that this is pretty close to the road. So Audium doesn't interpret. There's no interpretation whatsoever going on with Audium. It's all you understanding what's going on, being able to access that raw data and be able to make those judgment calls for yourself. So the road is there. You can understand that it's curving. You can understand that there's an intersection, but it's not necessarily going to tell you that you need to cross the road here, because that's an interpretation.
Okay, great. Thank you. Yeah, this is exciting. And then I guess the other thing, since you're still working on your PhD, is Audium ready, or is it still kind of in beta? You're working out the bugs.
I mean, we were the official CSUN map provider this year. We're going to be the official NFB map provider this year for their conference. We were the official ATIA map provider. We've done the JPL map, like I was showing there. We've also done Georgia Tech maps, University of Washington map. So we've done a bunch of different maps, and so we do have clients, and so we are commercially available at the moment. But thus saying, there is so many different types of representations out there and different types of maps with different levels of complexity. It's one of those things where I can't tell you, how much it's going to be to put one of these maps into Audium yet, because every map we encounter is slightly different and has different complexities with it. But for conference map, we've done a lot of those, so those are actually fairly simple to do.
Sure. Okay. Yeah. I'm just.
But yeah,
Hey, you might want to put me in touch with Brandon, because I'm just thinking one of my agencies that I work with is the Department of Natural Resources, and they have so many maps.
Yeah, for sure. None of them are
I don't know.
accessible. Yep, that's the
They
kind
may
of
not have the money for all those maps, but they have so many maps.
Yeah, for
Thank
sure.
you.
Yeah.
One of the things is, Kate, I observed on the map in particular is I liked the audio feedback on where you were going and approaching your source or your destination. And when you were on the skeleton, I thought that adding that audio ear con to what object you were on, like you're moving from one bone to the next, that allowed you to just move a lot faster without having to listen to the words. You could just and you didn't have to have it in your working memory for all that long. You just needed to hold that sound long enough to get to the next sound. And I think that's flippin' brilliant and an acknowledgement of how our brains actually work when we're moving around. So
Absolutely. So there's two ways that you can use Audium. Three ways that you can use Audium. One is through the visual experience. The other is through, an audio experience, and the other one's through the text experience. And it's really core that each one has a fully functional experience. And so I was demonstrating with the D key on the skeleton map that you can press that D key and it'll tell you where you need to go at any point in time in order to get to the location. We could have also turned on that radar and it would have beeped and gotten faster as we gotten closer. So it's just a different way of allowing you to access the information. So the D key was text, and the R key was audio. The R key is not WCAG compliant, so if we just had that R key, it wouldn't pass the WCAG compliance test. So we have to have that D key in order to be fully accessible, so that deafblind users can use it.
Yeah, I'm nodding. That's cool. That's very, very cool. Other questions?
This is Amy. Hi, Brandon.
Hey, Amy.
Hi there. One quick technical question. I tried this recently after I heard you on Double Tap again. It inspired me to go to my neighborhood, try the personal version. I could not figure out how to change the step size. I know that's a super
dash and equals.
Dash and equals.
There's
Okay.
a help command. So if you press H, it'll open up a dialog, a table with
Okay.
all the different key commands in audio. There's a lot of them. And
Okay.
so H is going to allow you to open up that table of all the key
H. Okay.
commands.
I'll remember that. My other question, though, is more going back to thematic maps and applications of these to maps of earth science quantities,
Yeah.
and it's true. I heard everything you said about an image file, a true picture image file. But there's lots of digital databases that are, well, digital databases. They're gridded, like take the topography of the earth,
Yeah.
elevation and ocean
Yeah,
depth.
all that can go into audio.
Yeah. Can I do that, or do you have to do that?
I have to do that right now. We're building an
Okay.
SDK so that you'll be able to do that eventually. Hopefully that'll be out in the next few months. But yeah, right now I have to do that. But basically, if we can get it in a GeoJSON format,
Mhm.
then even if it's points or whatever, we would probably if they're like for example, a lot of people will have maybe every 15 kilometers or something, there'll
Mhm.
be a new data point. Or
Mhm.
for
Yeah.
example, we did a sea level rise map. I need to show you
Yeah.
where we've have buoys that are located at different points around the ocean, and so in those particular cases, we can either have a bounding box that goes over every kilometer, or we can just put the point there and then make you have the interpretation of what that point means
Mhm.
in context to the map.
Okay. Yeah, I'd like to see how that works. And there's no way to move diagonally. It's just up, down, left, right.
I mean, you can go up and then left to move diagonally.
Yeah, I know.
You can
Right.
you can also rotate. And so I didn't show that in any of these demos, but you can spin around, and so if you want to, you can orient to a particular line or
Yeah.
sidewalks or make it so that the buoy is ahead of you, and then you can walk forward that way.
Mhm.
So in that way you can move diagonally.
And if you hold the arrow key down, to someone else was asking about going faster, I think it was Kate, so that you don't need the output, the audio text output, voiced.
Yeah, so if you hold down the arrow keys, I need to double check. JAWS sometimes crashes because it's getting so much text thrown at it.
Oh,
NVDA
yeah.
works just fine. VoiceOver works just fine with it.
Interesting. Okay.
Now, what we often do depends on what exactly. So I was holding down the arrow keys in the campus map example, where I was just holding down my right arrow key and I was just moving really quick, and you were just hearing the
Yeah.
of footsteps. And so NVDA, that's what the experience is, and it's usually the best experience. And if you don't have a screen reader, it's also the same experience. And then if you you can also press the control left and control right arrow keys, and that'll jump you to the next interesting object.
Oh,
And
really?
it'll tell
Okay.
you how far you've jumped. I think on production right now, it doesn't tell you how far you've jumped, but we're going to have a new update out in a few weeks where it will
Okay.
tell you you've jumped 36 meters and you landed on this feature. And
I
so
see.
that's going to help with allowing you to really quickly move around. And then if you move into the first person mode, so we've got a couple of different modes. I was showing primarily the grid mode here, which is all the text experience. But if you don't like as much text, then you can switch to a first person mode where basically you hold down the arrow keys and it'll allow you to have a step every number of milliseconds, and you can speed up that step to be however fast you want it to be. And so you can really quickly run around the map super fast, and that sometimes works better with JAWS.
Right. But in the topography case we were just talking about, if you were in that mode and you held the arrow keys down fast,
Yeah.
is there going to be some sonification option
If it's been
there?
added to it, yeah, for sure.
If
Yeah,
it's been
usually,
added, or you're going to add it? How does
yeah,
that?
I would have to add the sonification to it.
Okay.
So no, this allows you to add a sonification to it. Like, there's never been a situation where a topography map has had this kind of sonification added to it. So, future more research needs to be done to figure out how to most effectively sonify these types of maps. But my hypothesis would be that for a glacier, for example, we would want to use like an audio icon to show the glacier. For the elevation, we might want to use pitch for the elevation. And if you're really quickly moving around, yes, you can totally hear the sounds going up and down. And that's the best way to do
Explore.
the topography. Yeah.
Yeah, right. Okay, thank you.
Can I ask a question?
Yeah.
This is Cheryl Fogelhatch. I would really like to know about use haptics with this. Can you use it on a touchscreen and actually draw with your finger?
At the moment, the touchscreen experience is more similar to the keyboard experience. So
Okay.
how it works is you've got a little arrow pad where you double tap and it activates the map, and it brings up an up, down, left, right arrow key on the touch screen, and then you double tap to move one step, double tap and hold, and it'll move you forward repeatedly. And so at the moment, we don't have it to where you can move your finger around and draw. It's definitely something we just did a co-design with 10 blind participants on our touchscreen experience. And so I still haven't analyzed the data yet, but I'm guessing that they might ask about being able to do exactly what you just said there, be able to move your finger around and understand what's underneath the finger. There are a lot of cons to being able to do that. One of which is that there are often hundreds or thousands or tens of thousands of features on the map. And so how are you going to handle panning and zooming and all that kind of stuff if you've got all these different features on the map? Are you just going to like skip over them, or what are you
Or
going
if
to do?
it works like a monarch will work eventually. Yeah. Interesting. Thanks.
Yeah, for sure. Nicholas Giudice is somebody who's done a lot of work with the touchscreen map experience, and so he's one of the people on my dissertation committee. So he's definitely done some work in that space.
Okay, thanks.
Yeah.
Yeah, I'd also mention there's an app called Sonobally, which one of the other members of the Sonification World Chat, Fiadamsa, has worked on, and it's intended for kids, but you're using a touch screen and you're drawing shapes, and there's a sonification with it. So it seems like that could have some relevance for what you're working on, Brandon.
Yeah, for sure. It's called Sonification Valley.
Sonobally.
Oh, Sonobally. Okay.
And I think there's information on it on the Sonification World Chat website as well.
Yeah, we can direct you to that information later.
Yeah, for sure.
Yeah, that when I'm listening, Kate again here, listening to all of the discussion here and the interest level, and so I would like us to start really thinking about what for this organization, what might be something that we explore next. And Brandon, if you were to put a wish list out there for, what would you love to see someone do with Audium or partner with that would
I want Amy to use it professionally. I submitted a grant a few years ago trying, focusing on Amy in particular. And a lot of the feedback that we got from the reviewers was that how many blind oceanographers are there? And it's like, this is the chicken and the egg problem here. We've got a catch-22, and we are trying to break out of that catch-22. The catch-22 is that there aren't very many blind oceanographers because it's really hard to get accessible graphics, which means that people don't develop an interest in something like oceanography, and so they don't ask for the tools to be made accessible, and so future students don't have a really hard time getting access to the images or the accessible geography, and so they don't go into the profession, which means they don't request for the tools to be made accessible. So it's like this vicious cycle that we need to break. And there's so few people in the world who are professional, blind professional, scientists who use this kind of technology. So but there are a few, and Amy just happens to be one of the very, very few in the world. So that's kind of what I would like is can we make this into something that, you know, Amy can use in her research?
Okay,
Hard to believe the reviewers didn't recognize that chicken and egg problem.
I didn't
that-
spell it out for them because I didn't necessarily make the connection myself. So it, you know,
Okay.
you're right. And I was submitting it to NIH, not NSF. I think
Okay.
this was definitely more of an NSF.
Yeah.
And I'm also thinking, Kate, again, I think that the project that I been on the most years is the Afterglow Access software, where we're doing, where our goal eventually is to be able to allow anybody to take an astronomical image, identify asteroids on it and moving objects, and create a light curve independent of a sighted assistant. And I think that we have a rudimentary sonification tool, but when I look at this mapping ability, I'm wondering if that's actually not a better end, in rather along with being able to sonify an entire image and listen to features. But when you go to identify features and mark them, a mapping feature would be better. So I think we should be talking, one of the things I'd love to talk about is how to look for funding to put this into already created software that's online that has sonification capabilities, and see if we can mark and map and measure.
Yeah, 100%. Yeah, that's exactly what we want to be able to do. There's a lot of different. Oh, sorry. Yeah.
Sorry, I'm excited now. This is Chelsea. I mean, you could do a galaxy map. You'd have to make your distances giant, but you could.
Yeah, for sure. But distances are relative. And so if you're moving around, you know, for sure, yeah, we could totally do a galaxy map. We haven't done that yet, but I definitely could see how it could be done. If you have a galaxy map, especially if it doesn't have that many stars on it, because, you know, a galaxy map could have millions of stars on it. You know, we could definitely do that pretty quickly if it has, like, you know, 10, 20, 30. I don't know how many stars does a galaxy map usually have? I have no clue.
Well,
A lot.
What you
That would be
actually
Kate, though. I just had the idea.
Yeah, what you actually have on a galaxy map are not the stars, but the star forming regions. So you would have, they look like stars, sort of. They're dots, but the dots actually contain tens of thousands of stars, and the rest just looks like a bright blur. So it's a bright smear in a shape with the discrete, brighter areas. Like if you imagine a spiral armed thing with bright dots, that would be the points of interest within that.
Yeah, for sure.
Thing like a globular cluster, or even you just started with the Pleiades when you're talking about a dozen points. So I would start with the Pleiades, and I'll send that to you.
Yeah, that'd be great. And you know, of course, we have to also understand, like, what exactly is it that people are going to be interested in here, because we can say this is a star with a G heat classification or whatever. I took an astronomy class 15 years ago, so I'm trying to remember all my astronomy terms. But I think, you know, is it like the coloring of the star that indicates its heat? And so we would want to put that information in the title and also sonify that as what's important there. I don't know what other pieces of data are going to be super important on that star chart, but we want to make sure that everything is sonified and textified.
Okay, sounds like
Yeah, you could also add information about composition, atmospheric composition, chemical composition. But I'm also thinking another possible application, and this is more in the education aspect, is that there's a lot of curriculum that already exists, for example, through the My NASA Data group, and they have all sorts of curriculum materials using NASA data from Earth science missions, and they often use maps, but they're not necessarily accessible or easily accessed. So it would be interesting to take an existing lesson plan from the My NASA Data website and then see how your audiom could then be used with that, if the data is in a form that you could then apply it to, because then it would automatically make that material available to more people to use. And also the users that are already accessing it would have another entry point, as we've often discussed in this group. The multimodal, multi-sensory approach to education is very powerful for everyone.
Yep, 100%. I'm almost complete, like 95% sure that whatever lesson plan they have has a vectorized format underneath. So it's just a matter of, let's do it. But it might be usually it's a professional cartographer making the lesson plans, and they will have the vectorization somewhere. But maybe they only publish the pictures, so I don't know.
Worth checking.
Yeah, for sure.
Really good question. So I've
Yeah.
got them down, and this is fantastic. So Brandon and Chelsea, thank you both so much for being here. I think that we have some really juicy questions to go after from this that are starting to pull in a lot of the information that we've been hearing over the last few months. Let's start giving some thought to this and getting prepped for maybe an August push of what should we go after, because I don't think the opportunities are going to be jumping out of the federal government. We are going to have to create what we want and go find some interested parties.
Yep, 100%.
All right, with that, we are at the bottom of our 90 minutes, folks, and I appreciate y'all being here. We will see you next month.
Awesome,
Brandon,
thank you.
Let me know how that. Thank you, and let me know how that Esri conference goes, because if they bite, that could be huge.
Yeah, for sure. They definitely need people like you to be pinging them to tell them, hey, can you use something like Extra Navigation, like Audium from Extra Navigation to make Esri accessible? Because the accessibility team is actually the people holding the accessibility back. So it's just a kind of weird conundrum there. But anyway, we should definitely set up a meeting to chat.
Yeah, that'd be fun, because again, I'm interested in this both personally and professionally, and I'm stuck in the catch-22 right now.
Yeah, I understand for sure. Kate, can you introduce Chelsea and I?
Yes, I can. I was just going to make sure I did that after the call.
Awesome. And can you also send me over the Zoom chat? Because there's a bunch of links I wanted to see in there.
Yeah, and I didn't start typing in answers to some of the questions, because I've now come up with my new unverbalized policy of do not use the chat box when a screen of your user is presented. All right.
Awesome. Cool. Thank you so much for having me. And
Oh, it was great. It was great. These have been some great conversations.
Yeah, for sure.
I feel like your presentation was way better than mine.
Well, it was funny because I literally have that example that you were giving with the Google map as like my first slide, and that's what I usually present as like this is the problem. And so I'm glad that you did it, because it wasn't me saying this is the problem. Like this is actually, it gave it more weight.
Yeah, everyone in the state using Google Maps.
All right.
Or they make their own.
I'm going to sign off, folks. And
Thank you. Bye.
Okay, bye.